Hello everyone, welcome back to our channel where we explore the fascinating world of renewable energy. In this video series, we are diving into the topic of wind power generation from the basics to benefits. We'll explore how harnessing the power of wind can revolutionize our energy landscape. Wind power plants, also known as wind farms or wind turbines, generate electricity from the kinetic energy of the wind. They harness the wind's energy and convert it into electrical power through a series of steps. Before setting up a wind power plant, an extensive study of the wind resource in the area is conducted. This involves measuring the wind speed and direction at various heights over an extended period to determine the wind's potential and viability for generating electricity. Let's talk about working principles of wind power plant. Based on the wind resource assessment, appropriate wind turbines are selected for the site. These turbines come in various sizes and designs, and the choice depends on the factors such as average wind speed, turbine efficiency, and the intended capacity of the power plant. A typical modern wind turbine consists of the several main components. Rotor blades, large aerodynamically designed blades that capture the wind's energy and convert it into rotational motion. Nacelle, the housing atop the tower that contains the gearbox, generator, and other control systems. Gearbox. The gearbox increases the rotational speed of the low-speed shaft from the rotor to drive the high-speed shaft connected to the generator. Generator. The generator is responsible for converting the mechanical rotational energy from the wind turbine into electrical energy. Tower, the tall structure that supports the rotor and nacelle, placing the rotor blades at higher altitudes to access stronger and more consistent winds. The total wind power is equal to the incoming kinetic energy of the wind stream. Wind power is related with density of air, rotor swept area, and incoming wind velocity. Let's see about wind turbines. There are mainly two types of wind turbines that can be classified by rotational axis: horizontal axis and vertical axis. Horizontal axis wind turbines are the most common type of wind turbines used in modern wind power plants. They are characterized by their horizontal rotor shaft, which is perpendicular to the direction of the wind. To maximize energy capture, the horizontal axis wind turbine needs to align itself with the direction of the wind. The yaw system allows the entire nacelle to rotate horizontally facing into the wind. An anemometer and wind vane help determine the wind direction, and the yaw drive adjusts the nacelle's position accordingly. Horizontal axis wind turbines have 2 or 3 rotor blades attached to the rotor hub. These blades are aerodynamically designed to efficiently capture the wind's energy. As the wind blows, it causes the rotor blades to rotate around the horizontal axis. Sensitive to the changes in wind direction and turbulence which have a negative effect on performance due to the required repositioning of the turbine into the wind flow. Best locations for horizontal axis wind turbines are open areas with smooth airflow and few obstacles. Usually has 2 or 3 blades made of high-density glass fiber reinforced plastic. Diameter of rotor ranges from 2 to 25 meters. Modern rotors may be up to 100 meters in diameter. The wind energy is converted into mechanical energy by a turbine. This mechanical power is transferred through gears to the generator to increase its speed. Horizontal axis wind turbines are equipped with advanced control systems that monitor various parameters such as wind speed, wind direction, and turbine speed. These systems optimize the turbine's performance, adjust the blade pitch to maintain safe operation, and protect the turbine during extreme weather conditions. Vertical axis wind turbines are another type of wind turbine design used to generate electricity from the wind's kinetic energy. Unlike horizontal axis wind turbines, which have their rotor shaft perpendicular to the ground, vertical axis wind turbines have their rotor shafts parallel to the ground. They have unique features and advantages as well as some limitations. They have blades that radiate from a central vertical rotor shaft, resembling an egg beater or a helix. The number of blades can vary, but common designs have 2 or 3 blades. These blades are shaped to efficiently capture the wind from any direction. The vertical rotor shaft is the central axis around which the blades rotate. It can be made of various materials, including steel, aluminum, or composite materials, and is attached to the turbine's top and bottom support structures. They have a support structure that holds the vertical rotor shaft in place. The structure can be mounted on a stationary foundation or a rotating platform, depending on the design. There are 2 main types of vertical axis wind turbines. Darrow type. This design features airfoil-shaped blades that generate lift as the wind flows over them. Darrow's turbines are more efficient at higher wind speeds, but they often require external means, such as guy wires or additional supporting structures, to stabilize the turbine during operation. Savonius type. This design uses cups or scoops on the rotor blades to capture wind from any direction. Savonius turbines are known for their simplicity and ability to start generating power at low wind speeds. However, they generally have low efficiency. Vertical axis wind turbines are often used in small-scale applications, such as residential or community-based installations, and in niche environments where their unique design characteristics can be advantageous. However, for large-scale wind power generation, horizontal axis wind turbines remain the more prevalent choice due to their high efficiency and greater scalability. Horizontal axis wind turbines' rotating speed and failure rate are higher than the vertical axis wind turbines. Maintenance is also more complicated than vertical axis wind turbines. That's it for today's video on wind power generation. I hope you found it informative and inspiring. If you did, please give this video a thumbs up, subscribe to our channel, and don't forget to hit the notification bell so you won't miss any future videos on renewable energy. Thank you for watching, and let's meet with Wind Power Generation Part 2.